equations now with rational expressions. So with those problems we were doing before, we could not clear fractions because those were expressions. But if we have an equation, we can clear fractions. And of course, the way we spot an equation, it's got an equal sign. So to clear fractions, we multiply both sides of an equation by the least common denominator. That's what keeps the equation balanced. We've done the same thing to the right side as we've done to the left, so it's still an equivalent equation. And so with the equations, we're going to be able to clear fractions, get an equation without fractions, solve it, and we'll actually end up with an answer, a solution to the original equation after we're done. So here's a simple one. So we know, again, it's an equation because it has the equal sign, and we've got a lot of fractions. So first thing we do is we look at the denominator, the 6, the 2, the 3, and our least common denominator is going to be 6. Because that's the smallest number that 6 divides into evenly, 2 divides into, 3 divides into. So to solve, we're going to multiply by 6, which means we need to distribute so every single term gets multiplied by the 6. So we'll have 6 over 1 times the 5x over 6 plus 6 over 1 times the 1/2 and 6 over 1 times the x over 3. The ones aren't necessary, but a lot of people like to use those to help them line things up. So in the first term here, the 6's cancel out, leaving us with 5x. Here, 2 goes into 6 3 times. 3 times 1 is 3. And here, 3 goes into 6 2 times. 2 times x is 2x. Now you can see our equation looks much more friendly than the original one did. So to solve, then we can subtract the 5x to get the like terms together. That leaves us with 3 equals, let's see, to subtract 5x would be negative 3x. We can divide both sides by negative 3, and that gives us x equals negative 1. So we've got a solution at the end of all of this. We could take the negative 1, we can substitute it in for x, simplify, and verify that we've got a solution. So we're going to go on to more challenging problems than that, of course. But before we do that, let's take a minute and talk about the idea of domain, because this is going to affect some of our solutions. So with rational function, the domain often has to have some restricted values because we do not want to divide by 0. So for this particular expression, the denominator is x subtract 3. We do not want x subtract 3 to equal 0, so x cannot equal 3. So we've got that restriction on our domain for the function. So what you've got to watch out with these is sometimes you end up with what we call extraneous solutions. So if you're solving the equations, sometimes, not that you've done anything wrong, you just end up with a solution that does not actually work in the original equation. So it's really important to check your answers as you go. General process to follow. Factor the denominators and find the least common denominator. That will be composed of all the different factors in the denominator. Then we multiply each side, remembering to distribute to every single term of the equation by that LCD. And in this process of multiplying, we should be able to simplify and get a fraction-free equation. Solve that equation, and then be sure to check all the solutions in the original equation, the one with the fractions, and toss any extraneous solutions. So let's go through a few examples. This one, our LCD will simply be the two factors that we've already got in our denominators. So our LCD will be the x subtract 1. Oops, that's a 1. And the x plus 4. So if we multiply both sides by that x subtract 1, x plus 4, and this side of the equation by x subtract 1, x plus 4. If you like, feel free to put those over 1. And then we should be able to cancel out all of our denominators. So this x subtract 1 cancels with that x subtract 1, leaving us with a 3 and x plus 4 on the left side of the equation. On the right side of the equation, the denominator of x plus 4 cancels with the factor of x plus 4 in the numerator, leaving us with 6 times x subtract 1. So now we can simplify. We'll get 3x plus 12 equals 6x subtract 6. Subtract 3x from both sides to get our like terms together. we get 12 equals 3x subtract 6. Add 6 to both sides, and we get 3x equals 18. And then we can divide and get our solution, x equals 6. So is that actually our solution? We can go back to the original problem, so all the way back to the original one, the one with the fractions. And what we want to do is plug our solution in and simplify to see if they're equivalent, and also watch out for anything that would give us 0 in the denominator. So on the left-hand side, we get 3 over 5, and on the right side, we get 6 over 10, which reduces down to 3 over 5. So we do have a solution, and we did not have 0 in our denominator, so we know we're good. Okay, let's go ahead and have you give this one a try. I'll pause for a moment and see if we get the same solution. So did we end up with the same results? I had the LCD was x subtract 3, multiplied both sides of the equation by the x subtract 3. This canceled out my denominators, leaving my numerators. Solving, gathering like terms. Well, because I simplified there first. Distributed, got like terms, and ended up with x equals 3. So the question is, does x actually equal 3? And in this particular case, we do have an extraneous solution. Because if we go back to the original problem, we have 3 plus 5 over 3 subtract 3. So we're getting 8 over 0 on the left-hand side of our equation. Our right-hand side of the equation also has a 0 in the denominator, and that is undefined. So x cannot be 3, and we end the problem simply saying there is no solution to that equation. Okay, we've got another one here. This one's a little different in that we've got two terms here on the left-hand side. Our LCD will need the 56. We will need both the x and the x plus 1. The x in the x plus 1 expression is a term, not a factor, so that's why we also need to have this x. So our least common denominator will be x, x plus 1, and 56. Actually, let me rewrite that. That looks a little nicer to my eye as 56x, x plus 1. So I'm going to multiply through. So on this side, I'll have to, both this term and this term will have to be multiplied by that LCD. Okay, I've got it set up. Now the fun part, get to do some canceling. Those cancel out, and the 56's cancel out. So this removes all my fractions, and now you got to keep track of what's left. I've got the 56 and the x plus 1 times 1, so I don't really need to write the times 1 in there. Subtract the 56 times x times 1, so 56x equals, and then the 56 canceled, I'm left with the x times the x plus 1 times 1, so x times x plus 1. Again, fraction-free equation. If the fractions, if the denominators don't all cancel out, something went wrong, go back and check your work. Now let's multiply things out, gather like terms, and see what we've got to work with here. So distributing. With the x squared, I know I've got a quadratic equation. With quadratic equations, I like to set those equal to 0 to solve. On the left side of the equation, this is kind of nice. I've got a 56x and a subtract 56x. So those will cancel out, just leaving the 56 over here. And I can subtract the 56 to the other side of the equation. And then from there, I'll try factoring. If I can't factor, I can use the quadratic formula. My leading coefficient is a 1, so I know this is going to factor to x times x. I can try the guess and check. 56 is 7 times 8, And since it's a negative 56, if I use a plus 8 and a subtract 7, that way the positive times the negative multiplies to negative 56, and the 8x subtract 7x combines for a plus x, plus 1x. So setting each of those equal to 0, each of those factors, I get two solutions, x equals negative 8 and x equals 7. Neither of these is going to be a problem with our domain. The only problems that would cause trouble back here would be x equals 0 or x equals negative 1. And so this particular equation has two solutions. Okay, I think this will be our last one. This one, I would need to put a little more work into finding the least common denominator. Before I find it, I'm going to want to factor these quadratic forms here and see whether or not I've got some common factors. So this one's going to factor to a plus 1, a plus 2. This second term, that's a linear denominator, the a subtract 1. And then over here on the right side of the equation, a squared subtract 1, I recognize as being a difference of squares. So this is going to factor to a plus 1, a subtract 1. So when I build up my least common denominator, I need all my different factors as many times as they appear in any one denominator. So a plus 1 is here, and another a plus 1 is here. But it never shows up more than once in any one denominator, so I only need a single a plus 1 factor in my LCD. The a plus 2 I'll need, and then a subtract 1 shows up here and again here, but never more than once in any one denominator, so just the a subtract 1. So now I'm going to multiply this rather lengthy LCD times each of these three terms. I know, it looks horrible, doesn't it? But by the next step, things are going to be looking much better. And that's because a lot of these factors are going to cancel out. So here's the fun part. Those cancel, those cancel. That cancels with that. And the a plus 1's cancel over here, and the a subtract 1's cancel over here. So what's left here is a subtract 1 times 1, so a subtract 1. Bring down the plus down here, and then I've got a plus 1, a plus 2 times 1, so no reason to write the times 1. Need to bring along my equal sign. And then I've got a plus 2 times 2 left over here. Now I can do some multiplying out, gather like terms. But it is looking better now, isn't it? Because we've cleared out the fractions. So here I'm foiling. And on the right-hand side, I'll distribute. Okay, so I've got a quadratic. I got an a squared here. And then I've got 1a plus 2a plus 1a is 4a. So a squared plus 4a. Negative 1 plus 2 would be a 1. And then I can bring these two terms over. So with the quadratics, I want to set them equal to 0. 2a subtract 1 equals 0. Let's see. Hope I haven't made any arithmetic mistakes. Let's see. Oh, I did, didn't I? Right there. 2 times 2. That's a 4. That's a 4. Okay. I've got a 3 there, not a 1. So this is going to factor to a plus 3 and a subtract 1. Because 3 times negative 1 is negative 3, and 3a and negative 1a will give me my 2a. So I'm getting two solutions. A plus 3 equals 0 will give me a equals negative 3. a subtract 1 equals 0, add 1 to both sides, gives me a equals positive 1. So then, are these actually solutions? I need to go back and look at my original equation here. And the negative 3 should not be a problem, but the 1 is. If a is equal to 1, looking at this term here, 1 subtract 1 would give me 0, and 1 over 0 is not defined. So this particular solution is not a solution. It's an extraneous solution, and I actually only have the one solution to the original equation.